All right, here's part 2 of the video in teaching you how to do a pretty difficult concept. And I'm going to put a problem up here. This is more of a tutorial, which means you're not really going to do it along with me. I will give you one on the last slide that shows you how to do it along with me, but I'm going to teach you a pretty simple strategy to do what looks like a very daunting problem. It looks like a very difficult problem here. I'm going to put a pattern up. My pattern is 12, 19, 26, and 33. All right, and I'm going to teach you this, and this is why I want to tell you guys, this is why I'm so hard on the homework, guys. It's because I'm working pretty hard to put this together for you guys. I want to make sure you're taking advantage of it, and you're working hard here. The question is, number one, what is the pattern? But number two, what is the 68th term in the pattern? That, my friends, is a hard problem. And no, you can't answer it if you don't know what the pattern is. Well, let's look at it. We keep increasing by 7. So your first instinct would say plus 7, then the number before, right? Plus 7, plus 7, plus 7. But wait a minute. We're at the first term, the second term, the third term, the fourth term. Am I asking you to continue this pattern all the way to the 68th term? Ah, Dios mil! That's going to take a long time, guys. Well, I'm thinking of a couple different things in my head as we speak. I'm going to actually show you a very simple way to go about solving this. Think about it as a function table. What is the rule? Think about it as a rule. This is the same thing you just had on your test. To go from 1 to 12, what are you doing? You could list all the options. Well, I'm adding 11, but I'm not adding 11 to go from 2 to 19. Well, you could multiply by 2 and plus 10. But 2 times 2 is 4, plus 10 is not 19. This is where that little trick I told you to look at the rate of change is so important. Each one of these numbers is going up by 7. What is the only way that the numbers could be going up by 7? You must be multiplying by 7 because it's keeping that change constant. So if you multiply this by 7 and you follow the same rules, no matter what you're adding, if you're multiplying by the same number, which is 7 in this case, the difference will always be 7. So now that we know that, we don't need to try everything. You can think 1 times 7 would be 7 plus 5. Let's see. 2 times 7 would be 14 plus 5 is 19. 3 times 7 plus 5 would be 26. 4 times 7 would be 33. So if you want to find out the 68th number in the pattern, well, just keep that rule consistent. 68 times 7. 8 times 7 is 56. You should know this quickly. Carry the 5. 7 times 6 is 42. Plus 5 is 47. That's 476. Plus 5, don't forget the rule. 11, 8, that's 481. And you just solve that pretty quickly. There are probably other ways to go about solving this problem. You could extend the pattern all the way to 68. If you get bored at home, you want to try it, go for it. I guarantee you get 41. If you think about it too, if the fourth term is 33, then the eighth term would be 66, I think. The 16th term if you kind of keep doubling them, I want to see if this works. The 16th term would be 66 times 2, 132. The 32nd term would be 132. Doubled would be 264. The 64th term would be, oh no, that doesn't work. Alright, so stick to this. Anyhow, let me put another one up, and I want you to pretty much solve it along with me. In this next pattern, here's the pattern. 1, 9, 17, 25. The question is, in this pattern, what is the 82nd term? Well, so far, look at your pattern. Look at the rate of change here. Each time it's increasing by 8. Well, here's the first term, the second term, the third term, and the fourth term. Well, think about it as a function machine. Now, here's where it gets pretty tricky. It's increasing by 8, which means you need to be multiplying by 8. So 1 times 8 is 8. But how did I wind up at 1? I had to subtract 7. And you could have tried a whole lot until you came up with that. So you look at this. Let's make sure this works. 2 times 8 would be 16 minus 7 would equal 9. 3 times 8 would be 24 minus 7. That equals 17. So we found a rule that works. 4 times 8 would equal 32. Minus 7, 25. All right. So I know our rule works because I checked it. So now let's figure out the 82nd term. Well, I would just follow the rule. 82 times 8. 16. 8 times 8 is 64. That's 65. Minus 7. So minus 7. Let's make sure I did that right. Times 2 is 16. Times 8 is 64. It's 65. Minus 7 would be 649. I'll give you one to do on the next page. And you can put it on pause. Put it on pause as you're solving it. And then you can check your work and review it. So I'll write the problem. The pattern is all right, this is the pattern. Tell me what is the 72nd term in this pattern. I want you to do it. You can pause it, press play. I'll start going over it. All right, I'm assuming you turn this into a function table, which I've shown you how to do. Now, you're thinking, if this is the first term in the pattern, this is the second term, this is the third term. What do I need to do to get to 3? Well, you know that it's increasing by 7, which means it must be multiplying by 7. Just like our first one. So, but 1 times 7 is 7. So it must be multiplying by 7 and then subtracting 4. Let's check it. 1 times 7 minus 4 equals 3. 2 times 7 is 14 minus 4 would equal 10. 3 times 7 is 21 minus 4 equals 17. So our pattern works. What's the 72nd term? 72nd term would be 72 times 7 minus 4. 14, 49, that's 50, that's 504. Minus 4, we said. That would give you an even 500. So the 72nd term would be 500. Not so difficult when you have a really good strategy. turning it into function tables.